Hi, in this video I'm going to be talking about how to convert from rational exponent to radical format. So we've worked from radical square root signs to 1/4 roots and stuff like that. Okay, we've done that. Now let's go backwards. Let's start with the fractional and let's go to the square root looking sign format. Okay, so here's the first thing. This is the easiest one. If I have 1/3 power, that's pretty easy. That means I have 2 is what I was raising to the power of 1/3, and 1/3 is a cube root. So that's all I have to do on a problem like that, okay, is understand that 1/3 and cube root mean the same thing. What's tougher is if I have a number on the top of the fraction, okay, like a 3 or a 2. So in fact, let's go over this one here. 2 to the 1/2 power is simply 2, and I would have a 2 up here. But we don't really write the 2 because if I don't write anything at all, it's assumed that it's a square root, right? So we just write it as the square root of 2. 1/2 power, pretty simple. 1/3 power, pretty simple. 1/4 would be 4th root. 1/5 would be 5th root. The problem is, what do we do here if we have a 3 on top, a 3/2 root? Okay, a little bit more difficult. What you need to understand, a couple things to point out here. First of all, when I'm working with values like this, see that -2, the negative isn't actually involved with the exponent, because if I do please excuse my dear Aunt Sally, if I know about order of operations, I understand that I should be doing excuse exponents before I do things like multiplying by -1. Okay, so the negative here is not involved with the exponent. That's extremely important. That means that when I get to my final answer, I'm simply going to have a negative sign out in the front. What am I raising to the power? Only the 2 is being raised to the power. So only the 2 is going to be inside of my radical sign, okay? Now, how did I get the 3/2? If I come back over here, you'll notice that I took a 5 and I cubed it, and then I took it to the 1/4 power, right? 5 cubed, and then raised to the 1/4 power, and that's how I got a 3/4. That's how I got a 3 on top of the fraction. So we're going to work backwards, okay? Take that pattern and apply it backwards. What it means is I'm taking a 2 and I'm going to cube it, and then I'm going to square root it to get the 1/2. In other words, it's like having 2 cubed and then raising it to the 1/2, right? Properties of exponents backwards. 3 times 1/2 is 3/2. So I'm taking 2 and cubing it, and then I'm square rooting it. Now square root, once again, we don't need to write a 2 up here on the top, so we have our answer. I want you to also notice that I could have taken, if I wanted to, a separate method, okay, same value. I could have taken the 2 and square rooted it first, and then cubed it, okay, because that's like saying 2 to the 1/2 and then cubing it. And if I ever raise a power to a power, I multiply. Well, here's 3 times 1/2, here's 1/2 times 3. So if I wanted to, I could have also written negative square root of 2, there's a 1/2, and then cube that, and it would be the same thing. In other words, here's what I want you to understand. When I see the 3/2 power, I can either cube first and square root second, or square root second and cube, or square root first and cube second, and it would do the same thing. These are equivalent values. I can type them in my calculator. I can say negative square root of 2 to the 3rd power. That would be this example, right? 2 to the 3rd power is all inside the square root. It gives me this negative 2.82 value. Or I could have done negative, and I could have done the square root of 2 in the square root. Now I'll take that thing and cube it, and I get the exact same value. So it doesn't matter whether I cube inside the square root or after the square root, I get the same thing. That's how we get a 3/2 power. One more example. Negative 2/3 power means that, okay, so notice it's a 2 that I'm raising to a power. I'm raising it to a negative power. Whoa, whoa, whoa. We have to first do this. This is why this is tricky. Properties of exponents say that I can take a negative exponent, I can drop it down to the bottom of the fraction and make it a positive. So now I'm going to have 1 over a value. And here's what we're doing. Ready? I'm taking then, that's the same thing as 1 over. Let's put a little line here to denote I've spaced it. I'm taking 2 and I'm going to say square it and then raise it to the 1/3 power, right? That's how I get from 2/3, it's 2 times 1/3, 2 1/3, right? And so now that helps me see that what I really need is 1 over 2, okay? I've got 2 squared that I'm raising to a power, and 1/3 is the same thing as cube rooting it. So my answer is 1 over 2 squared to the cube root and the cube root of that. Now, you might notice then from the previous problem then, that also means that I could have cube rooted first and squared second. So I could also write 1 over, and I could cube root the 2 first. And then I could take this whole thing and I could square it, square the cube root. And that would be the same thing, okay? So 2 formats for the same answer. It's getting a little messy here, isn't it? 2 formats for the same answer. Both of those mean the same thing as 2 raised to the negative 2/3 power. In other words, what I'm trying to point out by doing these problems is the negative out front means it's just a negative value, a negative 2.82, right? But a negative in the exponent means it's actually on the bottom of the fraction. The negative in the exponent means it goes on the bottom of the fraction instead, okay? It's a positive 2. Notice it's a positive value. It's just now in the bottom of the fraction. So that's going to be a tough one, isn't it? That's going to be one we really need to think hard about, and whenever we're looking for patterns and we're looking for things that we can do in the homework, that's something definitely to pay attention to, okay? So hopefully that makes sense. I'll do one more problem. We're talking about evaluating expressions, but that's going to be another video.